Dear students, I welcome you for the today's lecture related to the flanges in the subject of chemical equipment design, or you can say the process equipment design. The flanges, which are most commonly seen for the purpose of connecting the pipes either to the pipes or to the vessels. So here you can see a huge pipeline, and the two pipes, they are connected with the help of flanges, and it is bolted completely for transferring the any earthing, the extra material, extra metal between the two bolts, that is also connected. Now, generally the flange, it is having the two faces, one and the second face that is available. In between these two flanges, the gasket that is provided so that it should not leak from the faces of the flanges. Even though we finish the faces looks to be the smooth, but there are minor gaps and which may lead to the leakages, and any leakages, either liquid or vapors, is not acceptable. So for that purpose, the gaskets, they are introduced in between the two flanges, which seals all the pores, and these two flanges, they are connected or tightened with the help of the nut and the bolt. So you will require the two faces, one face and the second face. The gasket you will require, and you will require the nuts and the bolts. That is the basic requirement of a flange, and it is for the purpose of preventing the leakage in between the connected pipes. That is, the flanges are commonly used to connect the cylindrical shells to the head. It can be welded, the cylindrical shell and the head, they can be welded. Generally for bottom they are welded, but for the top heads they are generally flange joints, so that the flange joints, they can be a temporary joint and can be very easily removed for the purpose of the cleaning, inspection, introducing the different material, different agitators or different systems inside the vessel. So all these different accessories that can be easily fitted inside any type of the vessel. Then not only to the shell, cylindrical shell and the head, it is also there are different nozzles which are available into the cylindrical shell, and we are going to connect the different pipes to this cylindrical shell or to the head. So for that purpose we are providing the flange joints, that is also the connection between the pumps and valves and the different types of the fittings. And this is a purely a temporary joint, so that it can be very easily and conveniently removed, replaced. But there are certain permanent joints also. These welded joints, soldered, fused, brazed, or adhesive joints, these are your permanent joints. But for the purpose of regular maintenance and cleaning purpose, or for separating the different equipments from pipes, for that purpose you require a temporary joint. By looking at this figure, it's a huge head of a shell and tube heat exchanger. Its dimensions are too huge. Then this is the pipeline which you can see the different flange, and the wall is fitted in between the two joints. A flange joint is a connection of pipe where the connecting pieces have flanges by which the parts are bolted together. That means it is the bolts which tighten the two parts of the flanges. The flanges can also be the plates. Now, what it can be? It can be a simple plate, or it can be a form of rings also, not necessarily always a plate. It can be a ring also, but mostly for the betterment, the people use in the form of a ring to form a rim at the end of a pipe when fastened to the pipe. Blind flanges, that is one of the type blind flanges, is a plate. So that blind flange, it aids the flow because it's a plate. The hole is not available. So although the word flange generally refers to the actual raised rim or the lip of a fitting, many flange plumbing fittings are themselves known as the flanges, not restricted to the specific plate and the ring type. So the gasket is inserted between the two mating surfaces. Okay. The flange is a part either casted, forged, or fabricated from sheet. So it can be a casted flange also. Sometimes to the pump, a household pump, the flanges which we see, they are casted also. Casted, forged, or fabricated from the sheets. Then one flange that is used to connect to the other flange by using the bolts or clamps or any other locking arrangement. So for the purpose of locking or for the purpose of holding the two flanges together in a leak-proof joint, we are either using the bolts, clamps, or other than that, so that they can be locked at their proper position. So these are again the different figures, that is you can see the flange which is available. This is the flange, this is also the flange. In between the flanges it can be a gasket, then the inserts that can also be fitted, because here the groove that is available in this flange. So this insert that is used to fill this gap, mostly very few flanges have such inserts. So these are the again the different types of the flanges which we will discuss in detail. Then what are the different materials of construction for flanges? It is mostly the carbon steel, stainless steel, alloy steel, brass, cast iron, bronze, aluminum, or nowadays the PVC and the other plastic material. They can also be used for the purpose of the flanges. Then there are certain different standard grades of all these materials. For carbon steel, for stainless steel, all these standards that is mentioned in case of your ASTM standards. So if it is a carbon steel flange, can be identified with a grade of F9 or F11. For in case of a stainless steel flange, the grade is F316 or F321, that is related to the F for the flanges. Now if it is a chemical, then the grade become 304 WP, 304 WP, 304 WP, 316, that is related to the chemical requirements, and this is related to the F is related to the flange requirements. Then there are sometimes the N term, that is also ASTM A105N. Now N stands for the normalized. That is, normalization is nothing but the heat treatment that is to be provided. So that is related to the material of construction. This normalization N refers to the material of construction. Then the selection of flanges. What are the different factors that are to be considered or to be taken into account for selection of the flanges? One is the selection steps for the pressure vessel flanges. and second is the other standards required for selection. This is first we will talk related to the pressure vessel. That is whether it's a design a tank or confirm the type of the flange. Then what must be the nominal diameter, then its working temperature, design pressure, material of the flange. Then nominal diameter and nominal pressure of the flanges, that is also to be given importance. At what pressure ratings that can be used, maximum pressure ratings. Then confirming the sealing face types of the flanges and the types of the gasket. Then according to the type of the flanges, whether it's a di nominal diameter or the nominal pressure of the flanges, checking and finding the dimension of the flanges. Then confirming the materials of the bolts and nuts, which material that bolt and nut should be. Then related to the other standards, that is the other standards may be required for proper mating of to the equipment and shall be revived at the time of generation of the material classes. That is first, which type of the flange. Now there are different types of the flanges. First we have to decide the type of the flange, which type of the flange I am going to select. Then what must be its rating. The rating terminology related to the flanges is very much essential. So at what rating? Rating that refers to the sustainable pressure and temperature conditions, so that it will have the specific dimensions for that flange, specific thickness, material of construction. That is all refers to included in your standard ratings. Then dimensional standards. What are the dimensional standards are there? Then flange facing, then the contact surface finish, then tolerance, material grade, additional material and testing requirements if it is applicable, the nominal size of the flange, then the wall thickness as defined by the scheduled weight or actual decimal wall. That is what will be the schedule. Then these are the some pictures related to the standard flanges. That is, one is the welded neck flange, which is the most prominent and dominating in the industries. That is the welded neck flange. Then second category is that the slip on flange. Then the lap joint flange, the blind flange. These are most common types of the flanges. This is the threaded flange. The threads are inner threads are available to this flange. Then the socket welding. So in this case, the groove that is available to form a socket, here you can see the groove that is available. So inside this groove, that is why it is the socket welding. Then the long welding neck that will be there. Then the ring joint, this groove that will be provided. This is nothing but the ring joint that will be provided. The next is the orifice flanges. You can see the orifice holes which are available to these flanges, so that this orifice, that is or the hole which will be penetrated inside this flange and will be directly exposed to the fluid. Then the nozzles, that is the change in the dimensions, here the reduction in the area, cross section area that can be observed. Then the blind and the spectacle, this is the blind and this is what is a spectacle. That is the blind and a spectacle arrangement that is also provided. Now these are the welded neck flanges, few figures. You can draw these figures very conveniently and easily. Then slip on welding, then integral, then socket welding, threaded flanges, then blind flanges, then lap joint flanges. No, these are more specific classes you can talk. This is the threaded flange. This figure uh, you have to draw it in your practical also. So this is the threaded flange which is shown. Then next is the slip on welding, slip on flange. Then the lap joint flange. Then this is the welded neck flange. Then the blind flange and socket welding flange. This is what the socket that is available here. Now the classification of the flanges, that is the flanges that is based on the standardization, based on the material used for the flanges, based on the geometry of the flanges, then the based on the facing and the special flanges. So these are the different categories you can it can be used for classification of the flanges. So that is related to the standardization, standard flanges. That means your specifications, they're defined by some of the standard, either it's a ASTM standard, British standard, or Indian standard. These standards are to be followed, and then the flanges are fabricated. They are costly obviously, but they are with the standards. Then based on the material used for the flanges, material of construction, then based on the geometry, different shapes for the flanges, because you require the different types of the shape, not necessarily always a circular shape that can be used, but that depends on your end use. In case of your carburetor that is rectangular with a certain uh, division or bifurcation that is provided, so carburetor of your two wheelers, so that will be there. So different geometries of the flanges, that will be also, oh, we are going to study. Then based on the facing, it's flat face or raised face flanges that will be there, and some special flanges will also be there. So one by one, based on the standardization. The standard flanges are based on the material of the fluid exposed, operating conditions, temperature and pressure, and the dimensions of connecting joint. Dimensions are fixed. So these are with certain ratings. That is, the it will be maximum operating temperature, maximum operating pressure, that is defined by that specific rating. Its thickness is also constant. So all these are the standard flanges, and they are classified as welded neck flanges, slip-on flange, socket weld flange, lap joint flange, threaded flange, or screw flange, then reducing flange, and the blind flange. So these are the different types of the flanges. One by one, we will go into the details of these flanges. The welded neck flange. Now looking at this welded neck flange, it is the tapered portion, upper section that is related to the pipe. So this is my pipe section. That means the remaining is the flange. Remaining section is my flange. And this is provided with a tapered section so that it a cross section area that remains constant, and it will be easy for welding purpose to the further pipe. So this is the that is why it is called a welded neck flange. Neck is provided, and this provided neck helps for easy welding purpose. That is why it is a welded neck flange. Uh, are easy, and the long tapered hub that is provided. This is the tapered hub that is provided. Reduction in the cross sectional area that goes gradually over to the wall thickness of the pipe fitting. The smooth transition from the flange thickness to the pipe or fitting, that is the flange thickness is of this dimension, and there is a reduction so that the pipe can be very easily and conveniently fitted. That is the smooth transition from flange thickness to the pipe or fitting wall thickness. affected by the outer is extremely beneficial under the conditions of repeated bending caused by the line expansion or other variable forces. Then these welded neck flanges are installed by welding the pipe to the neck of the flange. Then it allows this allows for the transfer of stresses from flange to the pipe itself, so that the traces will be transferred from the flange to the pipe. And this also reduces the high stress concentration at the base of the hub. This is nothing but your hub, that is also called. These welded necks are often used for the high pressure applications. The inside diameter of this attachment is machined to match the inside diameter of the pipe. Then the long tapered hub provided an important reinforcement. This serves as the purpose of reinforcement for the use in several applications involving the high pressure, sub-zero temperature or elevated temperature. So the additional thickness which is provided, this provides to operate it at a high pressure and high temperature. These flanges are bored to match the inside diameter of the mating pipe or the fitting, so there will be no restriction of the product flow, so that it is properly bored. The boring has to be done so that the fluid that can be easily passed, no restriction will be there and no turbulence will be created. The easy flow will be there without any disturbing the flow pattern. They also provide the excellent stress distribution through the tapered hub and are easily radiographed for flaw detects. So that is the testing part when it comes to the flanges. It is the radiographic testing which is mostly done to detect the different flaws. So these flange types will be welded to a pipe or the fitting with a single full penetration V weld. Usually these welded neck flanges shall match the metallurgy of the pipe in any material class. The authentic stainless steel, however, may in certain cases be interchangeable. So, for example, 347 and 321 stainless steels are combined so that the flanges that will be double clamped. Now the dimensions of that flange, it is specifically defined. That is the H which is available, B which is defined, this raised face that is also defined. So all these dimensions are to be defined. Each flange according to the ASTM B16.5 has a number of standard dimensions. This is related to the dimensions of flanges. If a draftsman in the Japan or any work preparer in Canada, there should be certain interchangeability, so that uh, classes 150, schedule 40, these are your specifications which are to be followed. Class and the schedule. Pipe, for pipes it's a schedule, and that is to be uh, restricted by the different fabricators. This is the welded neck flange with the class 150 and schedule 40. That is class 150 and schedule 40 represents the maximum temperature and pressure for which it can be exposed, and it defines the thickness also. So this is the phi that will be provided, phi that is your diameter. Then the next is the slip on flange. The first was a welded neck flange. Now it's a slip on flange. Now slip on flange, it is the uh, groove that is provided in the flange section, and that it is welded from inside as well as from the outside. So your pipe that will be welded or goes up to the bottom, and there is a certain sleeve which is available. So slip-on flanges are actually the side slide over the pipe. Slide over the pipe, that means it will be throughout can be passed, or it can be restricted there, so that the sleeve will be there which is going to restrict it, or it can be directly passed over the pipe also. They are typically machined with an inside diameter slightly larger than the outside diameter of the pipe. This allows the flanges to slide over the pipe, but to still have a somewhat snug fit. Then slip-ons are secured to the pipe with the fillet weld at the top and the bottom of the flange. These are your fillet welds at the top and the bottom of the flange. Nantar, these are further categorized as the ring or hub. That is the slip-on flanges. It can be categorized as the ring or hub. These rings and hub are both considered the slip-on flanges because they both fit over the pipe. Here the fitting over the pipe that is there, however, the pipe it will not cross the pipe in this case. The flange will not cross over the pipe. ओवर नहीं हो रहा है पूरा, but it is restricted inside the flange because of this available ring. So this available ring or the groove that is available, this restricts the further movement or further passing of the pipe through this flange. So that is the ring which is the provided, and second is the hub that will be there. The flange is slipped over the pipe and then welded both inside and outside to prevent the sufficient strength. The calculated strength from a slip-on flange under the internal pressure is of the order of the two-third of that of the welded neck flange. Now these welded neck flanges, these are the most strong one, and are specifically used for high pressure and temperature operations, where one cannot accept any leakages or breakages. There we are going to use these welded neck flanges. But there are certain situations where simple pipe water that is flowing, there I can compromise with the thickness. Instead of putting such costly flanges, I can compromise with the cost of the flange and can reduce the strength, which will be more cheaper flanges. So these are the internal pressure that will be internal pressure of the order of two-third that of the welded neck flanges. And the certain disadvantage of the flange is that the principle always firstly a pipe must be welded and then just a fitting. A combination of flange and elbow or the flange and T is not possible in this case. Then the important points for the slip-on flange, that is the slip-on flanges are flange cost is less than the welded neck flanges and require the less accuracy of the pipe cutting approximately. Slip-on flanges, okay. Then socket welded flange. So here actually you can see the socket on the ring which is available. So it has to be welded properly. That is the details of the socket and weld flange. These flanges are attached by inserting the pipe into the socket end and applying the fillet. Then next is a lap joint flange. Now in this lap joint flange, the a pipe that a sleeve lap joint flange, you can see the stub bend that is provided and the lap joint that is also provided. So this includes the stub bend and this lap joint. Now what happens, this stub bend will have the inside diameter of this bore and this will be going inside this. So it will look like this. So this is what the flange, this is the stub end that is available. This is the stub end which is available. And when this stub end, it can be very easily rotated. As it can be very easily rotated, the alignment of the flange with the other flange is more easy. So you can easily align these lap joint flanges, and which is a basic requirement for the ease of operation wise. This is again the similar to the slip-on flange, because your pipe, inside pipe is slipped over the flange. That is why it is also called the slip-on flange. But it has a radius at the intersection of the bore and the flange face to accommodate a lap stub end. So this is what a lap stub end which is provided in case of a lap joint flange. But the pipe can be passed through that. This type of flange is used in the applications where the section of the pipe systems need to be dismantled quickly and easily for inspection and replacement. That is what the alignment is very easy, and that is why it can be very frequently be opened. Then they may be used at all the pressures and are available in the full size ranges. These flanges slip over the pipe and are not welded or otherwise fastened to it. So bolting pressure is transmitted to the gasket by the pressure of the flange against the back of the pipe lap. The next is the threaded flange or screwed flange. So screwed flanges can be connected to the threaded pipe. Now inside of this bore, the threads they are provided, and to this bore I can directly fit a threaded pipe, so that it will look like either this figure or this figure. So here you can see the threaded flange fitted with a pipe. So these threaded pipe flanges are similar to the slip-on, except the bore of the threaded pipe flange has tapered threads. पाइप तो पूरा नहीं slip हो रहा है, but it is having the threads and which can be properly fitted. So these threaded pipe flanges are often used for small diameters, low pressure requirements. We cannot use it for the high pressure requirement because it's not a fixed joint. From the threads it may leak. There is a possibility. So that it is used for low pressure requirements. This obviously limits its application to the relevantly low pressure piping system. The flange may be welded around the joint after assembly, but this is not considerably satisfactory method of increasing its application. These threaded flanges are used for the special circumstances, with their main advantage being that they can be attached to the pipe without welding. That is what the special advantage of this. Sometimes a seal weld is also used in conjunction with the threaded connection. The threaded flanges of fittings is not suitable for the pipe system with the thin wall thicknesses. That is one of the limitations. because the cutting threads on the pipe will not be possible if the pipe thickness is less. Then next is the reducing flanges. In this reducing flanges, it will have the change in the diameters that is more prominently available. So reducing flanges are designed in compliance with the interchangeable quality standards. Then this includes a flange with a one specified diameter having a bore of a different or a smaller diameter. The difference in the bore diameter that is related to this reducing flanges. You can say the reducing or the expansion joints also. Then the blind flanges. These blind flanges, which are very common in case of our chemical industries, where we want to end the further flow. But in future, if you require, you can replace this blind flange and can be further used for the further use. These blind flanges are manufactured without a bore and used to blank off the end of the piping walls and the pressure vessel openings. So flow is restricted, blind, there is no further movement, hole नहीं है, bore नहीं है इसके अंदर. That is what a blind flange is. Generally, flange will have a bore that will be provided, but for blind flanges, there is no bore which is available. So the further movement of the fluid is restricted. Fluid cannot pass through that. Fluid cannot pass through the further. It will be restricted here only up to this point. So this can be the ending of the pipes. So this is a flange without a bore and is used to shut off a piping system or the vessel opening. It also permits easy access to the vessel or piping system for inspection purpose. This blind flanges can be supplied with or without the hubs at the manufacturer's option. Then these blind pipe flanges are used to seal the end of the piping system or pressure vessel opening to prevent the flow. Then they are commonly used for the pressure testing. For pressure testing purposes, that means the pipe has to be blinded at the two ends, and inside the in between these two blind ends the available pipe or the available vessel which is to be pressure tested. That means pressure testing, we are providing the pressure, extra pressure that is to be provided for the pressure testing. It's the hydraulic testing generally that is done. So pressure testing the flow or the liquid or the gas through a pipe or the vessel. They also allows the easy access to the pipe in the event that work must be done inside the line. Then based on the material used for flanges, that was the standard flanges. So all these above are the welded neck flanges, slip-on flanges, then blind flanges, then reducing flanges, then threaded flanges, and the lap joint flanges. All these are the standard flanges. Now next is the material of construction. The flanges that can be fabricated from carbon, stainless steel, alloy flanges, the different materials that can be used. The next category is the based on the geometry or the design. That is any different shape that can be given to the flanges, whether it can be rectangular, oval, elliptical, or even triangular that can be used. Now all these different shapes that can be provided. If you will go for the carburetor, you can see the different type of the flanges. For casted flanges in your household pumps, you can see this elliptical or oval shaped flanges. There are triangle flanges are also there. So all these are the different shapes or the geometries that can be taught. Now next is based on the facing. Facing, the flat face or raised face. whether the face is a flat face or whether it's a raised face. In that, the tongue and groove flanges that is available, the flat face flanges with the full face gasket shall be used. So plain flanges, male and female flanges, tongue and groove flanges, conical face flanges, and trapezoidal groove face flanges. Now looking at this figure, the plain face flange, these two faces that will be available, they are the plain one. Now the second figure, that is the male and female flange. This is the female cavity which is available, and the male protruding flange portion that is available, that is going to fix properly in this male female flange. Then tongue and groove, that is also there. A groove that is to be provided in the flange, on in one flange, and the tongue that will be provided on the another flange, so that will be properly fitted. The conical face flanges, the face of the two flanges that is going to change its shape. So in a conical format, in between these two flanges, the available will be the gasket that will be the available. The next is the trapezoidal groove face flange. So in between this tongue and groove, uh, one is the groove and one other is the tongue. In this case, the trapezoidal groove, both the sides you are having the groove, or sometimes the ring that can also be used. This is a trapezoidal shape that is provided, or a circular shape, or a hemispherical shape. Half hemisphere is on this side and half hemisphere is on this side. In between that, you can provide a ring also. So that ring type, that is more cheaper than this trapezoidal groove face flanges. The next is a flat face. If you will see all these figures, one section of this is shown corresponding to the other one. So this one section of the flange that is shown in this figure, the flat face that is available. So its a face is completely a flat one. It is not raised one. Now in this raised face, this is the raised section which you can see the raise is available. The change in the dimensions that is observed. This is the raised face. This is also the raised face. This is for the class 150, class 400. Then ring face, you can provide the ring, that is the trapezoidal groove face or the ring which will be provided, and it is half on this one side and half that will be available on the another side. So this is the another half, you can observe it. Then the larger small male and female flange. This is the male flange and this is the female flange. The protruding section that is available here and the groove that will be available in the female flange. Then it's a tongue and groove that will be available. Then a larger or smaller groove face flange. This is the groove that is available, and this is the uh, tongue that will be available. So tongue and groove, that is the flanges will be available. Now looking at this is the raised face flange. This figure clearly shows you or gives you the idea which portion of this flange is raised one. Only the inner diameter that is raised one, not the complete face is uniform. Only the raised portion that will be available. थोड़ा सा ज़्यादा है वो portion. So the different types of the flange faces are used as the contact surfaces to seal the sealing gasket material. Now in this case, the gasket that will be available only on this raised face. It will not be for the complete face. The gasket will be available only on this raised face. The contact will be only restricted to this raised face. So then the different various types. the flange facing the raised faces, the larger male and female facing flanges that will be there. Then it is a face called the gasket contact. Okay. Then here you can again distinguish the raised face, the different level of the raised faces that you can see in these two figure. Then the ring type, where we can then the flat face gaskets that will be available. This is what a flat face gasket, that fast flat face flange that will be available. Now the gasket that will be provided on the complete area in this section. Raised face, the gasket will be available only on the raised section. In the groove case, the gasket will be fitted only in the groove. This is the ring type joint flange are typically used in the high pressure and the high temperature services. They have the grooves cut into the faces